The last question I have selected to get you equipped with all you need to know in multiplying and dividing in standard form is this question that says that we should simplify 8.51 times 10 exponent minus 3 divided by 3.7 times 10 exponent minus 1. Bring out the number, no need of wasting much time. 8.51 divided by 3.7, then times 10 exponent minus 3 divided by 10 exponent minus 1. If you use a calculator, divide 8.51. We have 8.51 divided by 3.7. 3.7 is given out 2.3 times. What this means is this. Take their common basis. Exponent minus 3 because of division, minus, and what you are minusing is minus 1. So we are going to have 2.3 times 10 exponent minus 3, minus times minus will give you plus 1. You are having 2.3 times. This means 1 minus 3. And 1 minus 3 will give you minus 2. If you like, you can change this number to ordinary number by moving this sign of decimal towards the left across two places, because we have minus 2 as the exponent of 10. If you like, you can leave it like this. Whichever way you go, they have the same value. We are now into word problems in standard form. Word problems is trying to retrieve mathematical statements from sentences. That is what word problems in any area of mathematics means. Being able to extract mathematical representation from sentences. Just like the question we have before us. The question says Mount Everest is 8.848 times 10 exponent 3 meter above sea level. This is exactly the height of Mount Everest, which you know. I know you must have been hearing of Mount Everest as the highest mountain in the whole world. While Mariana Trench is 1.103 times 10 exponent 4 meter below sea level. Yes, Mariana Trench is the lowest surface below sea level, or the lowest surface on Earth's surface. Now, you are asked to calculate the vertical distance between the highest, which is the Mount Everest, and the lowest surface, which is the Mariana Trench on the Earth. For instance, if this is the sea level, Mariana Trench is here, one Mount Everest is somewhere here. So if from here to the Mariana Trench is this figure, and from this sea level to Mount Everest is this figure. If you want to calculate from Mariana Trench to Mount Everest, that means the depth of Mariana Trench plus the height of Mount Everest. That will give you the vertical distance between the lowest surface of the Earth to the highest surface of the Earth. So with that illustration, that means that the height of Mount Everest which is 8.84 times 10 raised to the power 3 meters, plus the depth of Mariana Trench, which is 1.103 times 10 raised to the power 4. If you add this to this, you will get the vertical distance from the Mariana Trench, which is the lowest below sea level, and the Mount Everest, which is the highest above sea level. In our normal process, what we have here now is, now there are two ways, just as we have been moving. But the way I'm going to take now is the way I feel like taking. In 8.84 times 10 raised to the power 3 and 1.103 times 10 raised to the power 4, you have 10 raised to the power 3 being common. Because there is 10 raised to the power 3 here, and there is 10 raised to the power 3 here times 10 raised to the power 1. So bring out that 10 raised to the power 3, or 10 exponent 3. Put your bracket. Divide 8.84 times 10 raised to the power 3 by 10 exponent 3, or 10 raised to the power 3. Discover that this 10 exponent 3 will cancel out 10 exponent 3 and leave you with 8.84. So write the 8.84 inside the bracket. Bring down the sign of addition. Do the same thing here. Divide 1.103 times 10 raised to the power 4 by 10 raised to the power 3. Discover that you're going to have 10 raised to the power 3 will remove 10 raised to the power 3 here and leave you with 10 raised to the power 1 and 1.103. So we are going to have 1.103 times 10 raised to the power. Simplify this. We are going to have 10 exponent 3 into 8.84 plus, if you multiply 1.103 by 10, you are going to have 11.03. Simply move the decimal point towards the right once, because this 10 has an invisible exponent of 1. Now you are going to use the calculator to add 8.83, or sorry, 8.84 and 11.03. 8.84 plus 11.03 is giving us 19.87. So we have 10 exponent 3 outside the brackets must be multiplied to 19.87. If you remove the bracket, what this means is 10 exponent 3 times 19.87. You can leave this in this form. That is meters now. Remember, you are asked to calculate the vertical distance between the highest and the lowest surface on the earth. Vertical distance is in meters, because each of those heights and depths of Everest and Mariana Trench were given in meters. So therefore, the answer you are going to have will be in meters. And remember that you are told to give your answer in standard form. That means, so you are going to have, what this is 19.87 times 10 raised to the power 3. So that way you can write this. This is not in standard form. If you want it to be in standard form, that means you're going to move this decimal towards the left once. Then you have 1.987 times 10 raised to the power 3 times 10 raised to the power 1. I'm not going to write the 1. Remember, you move the decimal once. That means you are going to have 10 raised to the power 1 added to whatever you already have. That means at the long run, we are going to have 1.987 times 10 raised to power 3 plus the invisible 1 here is going to give you 4. And is in meters. The next question we have is the wavelength of sodium light is 5,893. This is the symbol used in measuring the length or the wavelength of light. Now the question is saying that we should express this wavelength in meters in standard form. If one of these symbols is 10 exponent minus 10 meters. You are going to start solving this problem by one of this measure of wavelength is equal to 10 exponent minus 10. 10 exponent minus 10. Therefore, the value that is given, 5,893 of the wavelength. That means 5,893 of the same wavelength. Normal proportion is going to be equal to, when more, less we divide. Divide this by 1 and multiply it by that equivalent of 1. This divided by 1 will give you this. That means you have 5,893 times 10 exponent minus 10. So this is the value that you are going to get. So the only thing is you will now write this in standard form. And what you have here now is already in meters, because one of these is 10 exponent minus 10 meters. So the next thing we are going to do is to convert this to standard form. 5,893 times 10 exponent minus 10 will give us, since there is no point in between the numbers, that means there is a decimal point after the last number, but very invisible. Now move it towards the left until you have only one digit left in the left hand side of the decimal. So you are going to move it across 3,192,83, 3 places. So you are going to have 5.893 times the originally existing 10 exponents minus 10, then times 10 exponent, the number of places removed, 1, 2, 3. 3. It's going to give you 5.893 times 10 exponents minus 10 plus 3. If you take their common basis, which is 10, you add their index because they are multiplying themselves. That was exactly what I did. Minus 10 plus 3. So you are going to see that we have 5.893 times 10 exponent minus 10 plus 3 will give you minus 7. And this is minus 7 meters, because what we're calculating is in meters. This is the value of the wavelength, which is given in this figure here in meters. The diameter of the sun is approximately 1.4 times 10 exponent 6 kilometers. It has been a thing of approximation. Nobody have really told us exactly what it is. It's only God that will tell us what exactly it is. While the diameter of the Earth is also approximately 1.3 times 10 exponent 4 kilometers. The question is now saying that we should find the ratio of diameter of Sun is to diameter of the Earth. First of all, the number you have in standard form, change it to ordinary form. That diameter of the Sun and the diameter of the Earth. Diameter of the Sun, they said, is 1.4 times 10 exponent 6. And this means 1. Because of the 6, move the decimal point towards the right 6 places. Across 4, that is 1, 2, 3, 4, 5, 6 kilometers. This is the value of this. Then that of the Earth, 1.3 times 10 exponent 4. 1.3 times 10 exponent 4, which is something as move the decimal point towards the right 4 places. Across 3 is 1, 2, 3, 4 kilometers. So it is these two values now that you find their ratio. Finding their ratio is very simple. Write 1, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is to 1, 3 and 0, 3. Now, this is the ratio, but now we want to reduce the terms. Cancel 0 here, you can cancel 0 here, cancel this one, you can cancel this one, cancel this one, you can cancel this one. So we have 1,400 is to 13. Now let's go into significant figures. If you round this to one significant figure, it's going to be 1,000. Because all these things, all these values are values of that we get from approximations. So I want to round it up so that we get a figure of approximation and a figure that will be easy to handle. And if you should write 13 in one significant figure, it's going to be 10. So if we got this, if you remove 10, 0 here, remove 0 here, discover that you are going to have 100 is to 1. I think this ratio is better off. That means the ratio of the diameter of the Sun as against the diameter of the Earth is 100 is to 1. That is to tell you that the Sun is like 100 times bigger than the Earth. I could recall there was a day a student was asking me, how could the Sun you will be inside the Earth and be seeing be bigger than the Earth? You don't know how far the Sun is from the Earth that you are seeing. The truth is that from what mathematics have given us now, the Sun is like 100 times bigger than the Earth. The atmospheric pressure at the Earth's surface is 1.013 times 10 exponent 5 Newton per second, Newton per meter squared, approximately. The pressure at a height of 6 kilometers is approximately half of the pressure on the Earth's surface. Find the atmospheric pressure at a height of 6 kilometers. Give your answer in standard form. All this long grammar, what it wants us to do is to find half of 1.013 times 10 exponent 5. That's all. Write out the number 1.013 times 10 exponent 5 divided by 2. That is what they are asking for. Divided by 2. Write this number in ordinary form. That means you are going to move this decimal point towards the right into 5 places. It's going to now be 1, 2, 3, 4, 5 divided by 2. You can use a calculator or go straight forward. 2 divides 1 cannot. 2 divides 10 is 5. Nothing is remaining. 2 divides 1 cannot. You put 0. Some students they will make the mistake. They go and bring 3, 1 and begin to divide by 2 without putting 0 first. By then they will start having problem. When 2 cannot divide 1, put 0 before you break 3 to it. If you break 3 to 1, it will be 13. 2 divides 13 will give you 6. And that 6 times 2 is 12. Remove 12 from 13, you have 1 left. Bring 0 to the 1 to be 10. 2 divides 10 is 5. What is left is 0. 2 divides 0 is 0. That means the value you have is 50650. That means 50,650 newtons per meter squared. But the question says that we should give our answer in standard form. That means we are going to change this figure to standard form. It is going to give you, there is an invisible decimal point after the last digit. Move it towards the left until you have only 1 digit in the left hand side. So you are going to move it across 1, 2, 3, 4. And that will give the number of exponents you will raise then. So you're going to have 5.065. No need of putting this 0 here again because it has no meaning. Times 10 exponents 1, 2, 3, 4 decimal places that you have moved it. And this is going to be Newton per meter squared. That is the pressure, the atmospheric pressure at a height of 6 kilometers from the Earth's surface. A room measures 4 meters by 3 meters by 2.5 meters. We are asked to calculate the volume of the room in cm cube. Very, very important. In cm cube. The figures we are given in meters, and you are asked to calculate it in cm cube. Very, very important. Whatever you get here, change it to cm cube and give the answer in standard form. What this means is that the length of the room is 4 meters, the breadth of the room is 3 meters, and the height is 2.5 meters. Or in any other way, this may be the breadth, this may be the height, this may be the width. Okay? Or this may be the length. If this is the breadth, this might be the height. Whichever way, volume, which the question is asking for, is calculated as the product of the length, the width, and the height. That means the volume of that room is 4 times, this 4 times 3, then times 2.5, that is 2.5, all in in meter cube. 4 times 3 is 12. 12 times 2.5 is going to give you 24 plus 6, which is 30. You have 30 meter cube. Now, the main business of the question commences. You are asked to calculate the volume in centimeter cube. They are trying to know the ability in you in converting from smaller units of measurement to larger units of measurement. The truth is that 1 million cm cube gives 1 meter cube. 1 million cm cube is equal to 1 meter cube. That means, let's write it. Already we have 30 meter cube. That means 1 meter cube has the same value as 1 million. Million has 6 zeros. Centimeter cube. But now we have 30 meter cube by proportion. 30 is going to be, when more, less we divide. Just multiply it with this. We have 30 times 1 million. Centimeter cube. 30 times 1 million is 30 million. 1, 2, 3. 1, 2, 3 centimeter cube. Then the last, remember they said, after changing it to centimeter cube, also give the answer in standard form. Change. So we are going to change 30 million to standard form because it is in ordinary form. And changing it, there is an invisible decimal point after this. Move it towards the left until you have only one digit, only one number in the left hand side of that decimal. So you're going to move it across 1, 2, 3, 4, 5, 6, 7. And it's going to give you, that 7 will be the exponent of the 10. So you're going to have 3 points. You can put 0. Don't write the whole of the 0 because they have no meaning. You can even forget about writing the 0. Times 10 raised to the power 7. Because you move the decimal point, which is like an invisible full stop here, through 1, 2, 3, 4, 5, 6, 7. That's why you have 10 exponent 7 here. Remember, centimeter cube. The earth weighs approximately 6 times 10 exponent 24 kilograms. How did they find it? Let's believe it. While the sun weighs approximately 2 times 10 exponent 30 kilograms. How they achieved it? I don't want to say anything. The question says, which is very important to me and to you, that we should express the ratio of mass of the earth is to mass of the sun in the ratio, in the form x is to 1. That means, pay very acute attention, mass of the earth should be in the left hand side representing x, while mass of the sun should be in the right hand side representing 1, where x is a number in standard form. That's just another way of telling you whatever you have as the ratio of the mass of the earth, which should come first, let it be in standard form, and it should be E is to 1, the mass of the sun. Okay? Let's take the mass of the earth, which they said is 6 times 10 exponent 24 kilograms. is going to be to the mass of the sun, which is 2 times 10 exponent 30. If you want to change this to ordinary form, you begin to write from here and it will end maybe somewhere here, because you are going to be adding 0 until 24th time. So it's going to be a waste of space and time. Look at how easier we are going to do that and save ourselves the stress of writing 0 until the whole whiteboard is filled up. Now we have 30 here. You either reduce this exponent of 30 to 24 so that you can cancel off, or increase the exponent of 24 to 30 so that you can cancel off. Let's choose changing the exponent of 10 here to 30. And when you are doing it, that means you are going to reduce, because here now there is an invisible decimal after 6. You have 6 digits before you get 30 from 24. And that's 6 digits. If you must change this 24 exponent of 10 to 30, you must reduce or move the decimal point towards the left 6 places so that the value will still remain the same thing. What I mean is this. We're going to have 6, 1. I said from 24 to 30 you have 6 digits. So we are going to move the decimal point here towards the left 6 places. Across 6 is 1. You have 2, 3, 4, 5, and 6. You can put points, you can add another 0. So if you now say times 10 exponent 30, the value of what you have here is the same thing as 6 times 10 exponent 24. We only change it to exponent, this 10 to exponent 30, so that it will be easy for us to cancel out the exponent of 30 you have here, which is 2 times 10 exponent 30. Now you can forget about this and pick these figures. In the left hand side you have 0.1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, then 6 is to 2. Remember from the question, x should be in standard form as the question demands. Y2 should be 1. So what I want to do now is to divide 2 by 2 to give you 1. And divide this by 2 to give you 0.1, 2, 3, 4, 5, then 3. 2 divide 0 is 0, 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 divide 6 is 3. That was exactly what I did. So it's going to be, this figure is to 1. So we have gotten to the last, because 1, it should be represented in the right hand side, and that should be the ratio of the mass of the sun, while this is the ratio of the mass of the earth. But the next thing that is remaining now, because they said where x is in standard, sorry, where x is a number in standard form, that means we want to change this to standard form. So if you want to change it to standard form, you're going to move the decimal towards the right 2, 3, 4, 5, 6 places and multiply or put 10 to the exponent of minus that number of places you went, because you move from the left to the right, as in you move the decimal from the left to the right. So you are going to have 3 times 10 exponent minus 1, 2, 3, 4, 5, 6. Exponent minus 6 is now is to 1. That's exactly what the question say you should do.